So we've looked at one of the two different styles of logarithmic axis plotting and graphing. What I'm going to do in this video is I'm going to give you a couple of questions based on that style that we've looked at. I want you to read the questions, pause the video, have a go at them, and then come back and check your answers with the work solutions I'm going to do here. So here you go, here are the questions. First one, two variables x and y are related by the formula y equals ab to the power of x. When log to the base 3 of y is plotted against x, the graph passes through the point 0, 2 and 2, 0. Find the values of a and b. And the second one, I've given you a plot there. Find the formula of the form y equals ab to the power of x when I plot log to the base 10 of y against x, and I give you 2 points that the line goes through. So pause the video and have a crack at them. Come back and check your work. So the first one, two variables x and y are related by that formula. Log to the base 3 of y is plotted against x. The graph passes through those points. Find a and b. So for this one here, remember we take y equals ab to the power of x. And what we have to do is when log to the base 3 of y is plotted against it, we have to take log to the base 3 of both sides. So it's log to the base 3 of y equals log to the base 3 of ab to the power of x. Now this side here, we split up using our rules of logarithms. So it's a times b. So what that means is log to the base 3 of a plus log to the base 3 of b to the power of x. And again, we can use our rules of logarithms to bring the power down here. So we've got x times log to the base 3 of b plus log to the base 3 of a. Now if we were to think about our formula y equals mx plus c, this would be in that version there. Our log to the base 3 of b would be our m, our gradient, and our log to the base 3 of a would be our c, our y-intercept. So we can calculate both of these using those facts. Now our y-intercept, where it cuts the y-axis, we can actually read that off because it's this part here. Because we then can say that log to the base 3 of a equals 2. That's where it cuts the y-axis. So I can rearrange this and find out what a is. From that, I know that a is equal to 3 squared, using our rules and bringing that up. So it's 9. So I then know a is equal to 9. And I could do the same sort of thing for b. Now I know log to the base 3 of b is equal to the gradient, and I can calculate the gradient using these 2 points here. So using y2 minus y1 over x2 minus x1 gives me 0 take away 2 over 2 take away 0, which in this case gives me negative 2 over 2, so it's negative 1. So what I can then say is fine, so I know then that log to the base 3 of b equals negative 1. Same idea, take this up, and I get b equals 3 to the negative 1, so b is equal to 1/3. And what I can then do is take the values I now know for a and b and use them to get a formula if it asks. Now all it wants us to do is find the values of a and b in this question, so I'm fine here. I've got my a and I've got my b. But I can combine them if I want to make a formula if the question so asks, like the next one does. I want to find the formula in this form for this graph here. So it's got log to the base 10 of y plotted against x, and I've got 2 points here. So 0, 0.7 and 2, 1.9. Now again, we start with our y equals ab to the power of x, and it's log to the base 10 of y, so I take log to the base 10 of both sides. Again, I can use my rules of logarithms to split this up the same way. I get log to the base 10 of a plus log to the base 10 of b to the x. Bring the x down, and I get x times log to the base 10 of b plus log to the base 10 of a. And again, we can similarly think of this in our terms of y equals mx plus c. The log to the base 10 of b is our m. The log to the base 10 of a is our c, or y-intercept. Looking at the points here, well, I can actually read off my y-intercept from this point. I know that log to the base 10 of a equals 0.7. Bring this up, and I can say, fine, a equals 10 to the power of 0.7. Now, at this point, I'm just going to leave it. I want a formula in the form of ab to the x. This will get simplified later on when I combine it all. What I can now do is use the gradient part to get my log to the base 10 of b. Now I know the formula for the gradient, y2 minus y1 over x2 minus x1. and I can use the 2 points to get it. So y2 minus y1 is 1.2 over x2 minus x1, that's over 2. Now that's the equivalent of taking that and making it 12 over 20, which then simplifies down to 3/5. So I then know log to the base 10 of b equals 3/5. b equals 10 to the power of 3/5. So I've got my a and I've got my b. What I can now do is write them in this formula. I can then say fine, so now y equals a, which is 10 to the 0.7, times b to the power of x, which is 10 to the 3/5 x. And I can then combine the whole shebang together and make it one simple little formula. So multiplying these two together, same base, we can add the powers. So it's going to be 10 to the power of 0.7 times 3/5, 0.77 over 10. Combine the two of them together, get 21 over 50 x. So that right there is the formula we are after. We've written y in the form ab to the x for this line. That's what we're after. So if it asks us to give the formula, we have to write it like that. If it doesn't and it just wants the values of a and b, we can just leave it at that stage where we say a is this, b is this.